Hi everyone, Quiveen here from the comfort of my kitchen. Just a couple of videos ago, we took a look at some galaxies and how those galaxies are often classified by shape. Now that we're getting into the month of February, our own galaxy is starting to be visible once again in morning time. So we're going to move forward to just before sunrise here. We can see the Summer Triangle over in the east and Scorpius down here towards the south. If we head out to the countryside, and we are going to head out to a perfectly dark sky, this early in the month, we're not really getting to see the glow. You might see a little bit of the Milky Way there, but we're not really getting a good view thanks to the moon, which will still be very close to full on the 4th. Here we are 93.4% full, so still pretty full. Definitely producing enough light to interfere with our view of fainter objects. As we move later in the month, the moon will move out of the way, but the sunrise will also be getting earlier. The sky will be getting brighter earlier, so you need to go out earlier to see the glow of our galaxy. So here we are just about 6 o'clock in the morning on the 18th, and we've got the glow of the Milky Way. And we can see the different colors in the Milky Way here. They're even more obvious. Sometimes they're more obvious to the naked eye, or if you take a photograph, that can also make them more obvious. But you should notice down here towards the southeast that the galaxy has this sort of reddish glow, almost a reddish orange, and we can see that across this area of the sky. Whereas out towards the arms of the galaxy, we're seeing a lot more of this kind of pale, milky, sort of a milky blue color. That is the color of our galaxy. In towards the center, we've got that kind of orangey red, and out towards the edges, we've got that kind of smoky blue color. And our galaxy is a galaxy. We're a spiral galaxy, and as I mentioned in the previous video, we are a barred spiral galaxy. In the previous video, a couple of videos ago, we took a look just in here, between the tail of Leo the Lion and the head of Virgo, just to see some of the galaxies that are actually quite near to us in the local group. But for this example, we're going to start by turning around to the north. We're here again, oh, I've turned too far. We're here again in morning time, which puts the Plough or the Big Dipper right above the North Star at this time of the year. So we don't even really have to look into the north. We could be facing south and just lean back to look up at the zenith or zenith, depending on how you pronounce it. Taking a closer look here at the handle of the Plough or the Big Dipper, we're already seeing a couple of those fuzzy shapes, which we now know to be galaxies. If we take a closer look at the Whirlpool Galaxy, a fantastic example of a galaxy known as a grand design spiral galaxy because of how obvious its arms and its shape is. You can see that it has that kind of, I guess, more yellowy, dusty color towards the center. It's got some of these dust lanes in its arms, which also have that kind of darker, almost reddish color, but a lot of its arms are this wonderful blue. This blue color, and you can really see it here when we zoom in, these blue dots are stars and star forming regions, and we can see there's quite a lot of them. The Whirlpool Galaxy is still a young enough galaxy with enough of the gas, enough of the hydrogen gas clouds to power the formation of stars, as well as having some of this dusty material. Dust scatters light, the same way the air scatters light. When light gets scattered, you're usually scattering out the higher energy wavelengths first. The higher energy wavelengths tend to bounce around and get thrown away by things that are in the way a little bit more. Here, looking at the sunflower pinwheel, the pinwheel galaxy, we've got plenty of those bright star forming regions. It still has that kind of yellowish color in towards the center. Some of the other galaxies that we can see really all over the sky, but we're going to look for the ones that are close to Virgo and Leo up in this direction. As we start zooming in, we should start seeing some of those fuzzy spots. Here we go, and those are the galaxies that we are looking for. Because there's so many galaxies in this region, we're going to get a better idea of their variation, and we're going to get to see some spiral galaxies that are a little bit more on the orangey red end of the spectrum. When stars form, there is often the formation of bright young blue stars, and there is the formation of red stars, red dwarfs that last a very long time, and over the course of their lifespan, stars will age, they will change, they will go from being young and bright and blue to being more old and red and orange. Blue stars with so much energy burn through their fuel very, very quickly. So in older galaxies, we're looking at M98 here, we're not seeing a lot of blue here at all. Maybe a little bit down here, but the vast majority of the galaxy is this orangey yellow kind of color. And that's because most of the blue stars in that galaxy have died out and there's not enough hydrogen left to keep forming new ones. So although galaxies aren't directly classified by their color, the color of a galaxy can tell us a lot about the galaxy and its history. Taking a look here at M90, we've got a very similar effect going on. It's got this yellowy color towards the center, almost this smoky gray towards the outside, but it doesn't have those blue colors. The fact that the arms of our galaxy are blue tells us that our galaxy is still producing blue stars, because blue stars don't last very long. With these other galaxies, if we're seeing blue, we know that this galaxy, here we go, M58 in this case, with these blue bands, we know that this galaxy must have still been creating new stars within the last 100,000 years or so. Otherwise, these blue stars would have died. They would have collapsed, either gone supernova or nova, either fallen apart or collapsed and exploded, depending on the size of the stars. Those blue stars don't last as long. So when we see galaxies that are rich in those blue stars, we know that it's still active, or well, not an active galaxy. Active galaxy usually refers to how active the black hole is in the center, but we know that the galaxy must still be forming new stars. When we see these yellowy reddish colored galaxies, that's an indication that the galaxy is no longer forming new stars. All the blue stars have burned out and they haven't been replaced by new star formation the way they have in these bluer galaxies. But we can also see that even these blue galaxies, even these galaxies that very obviously have this lovely blue color, and here's a good example of a barred spiral galaxy, even with this rich star formation in the arms, it still has that yellowy color towards the center. And a lot of that is due to dust. Because the dust in the center is able to scatter light and spread out the energy of the blue wavelengths of light will lose energy from bouncing around. They'll shift to red, not the same red shift that we get from galaxies that are moving away from us very quickly, but the same kind of red shifting that we get when we see an orangey yellow sunset. During the day, the sky looks blue. But as that gets spread out by our atmosphere, because it's going through more atmosphere when it's coming through at a lower angle as it does at sunset, then we start getting more of these yellows and oranges. Now with this Silver Streak galaxy, not seeing loads of blue either, so there's a good chance that that galaxy is at the older end after losing or using up a lot of its hydrogen. Our galaxy follows the same rules as every other galaxy. The patterns that we see in other galaxies, they hold true for our galaxy as well. So coming up here to morning time, we can see it towards the center of our galaxy, even though we still have areas where new stars are being formed. And if we take a closer look in here, we can see nebulae where star formation is occurring. But there's so much dust and gas that a lot of the color that we're seeing here is more of that reddishy color. Out towards the arms of the galaxy, there's still lanes of dust and gas, there's still regions where light is getting scattered, but we're also getting more of that bluish background color because there is still young blue stars forming in our galaxy. So the color of galaxies, it's not normally a way that we divide up or classify the galaxies, but it is more valuable information. These galaxies are different colors for particular reasons, and by looking at these colors we can get a better idea of how that galaxy is behaving, perhaps how old that galaxy was, and in some cases even get an idea of how galaxies are interacting. If hydrogen gas is being pulled out of a galaxy by its neighbor, very often that gas will be compressed and we'll see it as a spate of new star formation. We might be able to see that, in fact, in the Whirlpool galaxy, which is swallowing up one of its smaller companions, one of its satellite galaxies. So we can see there's a lot of dust and gas here, but we're also seeing star formation along those dust lanes. And that's just a galaxy swallowing up a smaller one. When two galaxies of a more equal size come together, and we'll go with the Antennae galaxy, which is a galaxy we looked at in the last video where we looked at galaxies. It might be 2 in the horizon. No, it's not too bad. We'll get rid of the atmosphere just to make the view a little bit clearer. Loads of blue here, loads of new star formation, because the hydrogen gas that was in these two galaxies is now getting smushed together by the collision of those galaxies, and that driving together of the hydrogen is spurring new star formation. Seeing as we looked at the shape of galaxies in a recent video, I thought it would be appropriate to take a look at the color of galaxies in this video, especially with our galaxies stretching across the sky. And I hope you get to see our galaxy now that we're in February and we're at a good time for it to be seen. But of course, if you have too much light pollution, it won't be visible. But at least you've gotten to see it here. I hope that you enjoyed this video. If you did, please do like it. And if you enjoyed this kind of content, then please subscribe to this YouTube channel. If you'd like to read some of this information, you can do so on my website, queevinscontent.ie. Thank you very much for watching, and hopefully I'll see you back here next time.